Hey Pre-Calc students, in this video we're going to cover some applications of vectors. Some of the biggest applications of vectors involve movement. Two ways we can describe movement is just like position, so where something is located, velocity, and when we're talking velocity, we're talking something that has both a magnitude and a direction. The magnitude of velocity is what we call speed. And then we talk about the direction that speed is heading in. So velocity can be both, it's a direction plus the speed. And then there's acceleration, which also has a magnitude. So you can accelerate a certain amount, but then it can also have a direction applied as well. So if you're moving forward, but your acceleration is in the opposite direction, you might think about this as deaccelerating. So movement is a big application of vectors. This is a concept you would study a lot more if you take a physics class or a calculus class. Okay, so I have example 1. A plane is traveling with a bearing of 30 degrees east of north at a speed of 400 kilometers per hour. Draw a picture of the path of the plane and describe the motion of the plane as a vector, as a velocity vector. Okay, so the first thing that I'm going to do is I'm going to draw first kind of a compass to get us oriented because we're talking about north, south, east, and west. So I'm going to draw a compass and I'm going to build my compass. I'm going to put north at the top, south at the bottom. I'm going to put west and then east. Because these are oriented on a plane, I can also give these degrees. I'm going to match these degrees to the ones I use for unit circles. So east, I'm going to say is 0 degrees and 360 degrees. North is 90 degrees. West is 180 degrees. And south is 270 degrees. Okay, so now I have my compass set up and I am going to draw this plane vector. So the first thing I want to understand is what is the angle that this plane is making. So if I look and I find my bearing angle is describing 30 degrees east of north. So this east of north is I need to go towards east from north's direction. So I'm going to start at 90 degrees and I'm going to go 30 degrees to the east direction. If I do that, that's going to put me at 60 degrees. And so that's the angle that my vector is going to be drawn at. I'm going to draw an angle that is at 60 degrees. Okay, so once I've got that angle drawn, I need to know the magnitude or the length of this vector. So the magnitude we just talked about for velocity is speed. So speed here is my magnitude. So this is going to give me a length that this vector is moving. It's moving with a speed of 400 kilometers per hour. So I'm going to mark that this angle, that this vector is happening 400 kilometers per hour. Okay, so there's my plane that's been drawn. So this is kind of the motion that the plane is heading in. And then it says to describe this motion as a vector. So not only draw the vector, but we also want to then use vector notation. So I'm going to set up a component form of my vector. So to find the component form of my vector, I need my x and my y. So again, to do a component form of a vector, I'm going to use the bracket notation. So I need x and a y's position location for this vector. And to do this, I'm going to use those formulas that we got in our last video. So to find x, I need the magnitude times the cosine of the angle. So I've got my magnitude. And actually, let's write these formulas up at the top. So x equals the magnitude times the cosine of the angle. And y is the magnitude times sine of the angle. Magnitude is 400. Angle is 60 degrees. I'm going to use my calculator to find these values. Make sure your calculator is in degree mode. My x value is 200. And again, this is an X kind of velocity, so I am going to still use kilometers per hour here. And then my Y value is 346.4 kilometers per hour. So this is going to give me an overall motion vector. This motion vector stands for the velocity, and it's describing how this plane is moving in terms of the X and the Y. So 200 kilometers in the X direction, or in this case, east direction, and 346.4 kilometers per hour in the north direction. Okay, so the hardest part about these problems is knowing how to set your vectors up. So again, to find your X component of your vector, you want to do the magnitude of the vector times cosine of the angle. And to find the Y, you want to do the magnitude times sine of the angle. Okay, so the first thing I'm going to do is I'm going to set up a compass, so that way when we're talking these examples, we have a compass drawn. And the main thing is the magnitude they kind of describe as the speed. So what we were really trying to find is the angle measurement. And you want to be careful based off of the description of how to draw the angle. So the first one is 50 miles per hour, south, 45 degrees east. So I want to start at south's position, and I want to pivot 45 degrees to the east position. This is going to put me at an angle measurement of 315 degrees. Once you have your angle measurement, to set up your vector, all you need is to find the X position by doing the magnitude times cosine of the angle and the magnitude times sine of the angle. Make sure your calculator is in degree mode, and then we're going to let our calculators do this work. So 50 times cosine of 315 is a positive 35.4. And 50 times sine of 315 is a negative 35.4. And again, this is an X and a Y position for every mile per hour. In other words, whatever is moving, whether it's a plane or a boat or a car, they're moving 35.4 miles in the X direction, and then they're moving per hour, and negative 35.4 miles in the Y direction, miles per hour. Again, we're finding an X and a Y position for these. So, okay, let's take a look at the next one. We have an angle measurement of 30 degrees west of north. So west of north means I need to start at north and go 30 degrees to the west location. So I'm going to take my 90 degrees and I'm going to go 30 degrees towards 180. And that's going to put me at 120. You can think about this as just kind of like adding 30 degrees. And then I'm going 200 kilometers per hour. To set up my vector, it's magnitude times cosine and the magnitude times sine. Again, letting the calculator do this work for us. Okay, I'm going to let you try the last three on your own. Keep in mind, the due north is talking about straight towards the north position. So pause this video and see if you can give the last three a try. Okay, check your work and see how you did. Again, these should have been all the answers that you should have gotten for all the vectors of this motion. Okay, the remainder of examples that we're going to cover is what happens when you start to combine vectors or vector motion. Okay, for this example, we have a pilot that flies a plane due west for 150 miles, then turns 42 degrees north of west for 70 miles. Find the plane's resultant distance and direction from the starting point. Okay, so the first thing I'm going to do is I'm going to set up my compass. And now I'm going to pick out my directions and then any changing directions. So the first says a pilot flies due west for 150 miles. So I'm going to draw a vector going towards the west for 150 miles. I can find this vector by doing my vector formula. Okay, so we have this movement after however much time it's been. We've gone negative 150 miles in the x direction and then 0 miles in the north or south direction, or the y direction. Okay, so then we're going to turn the plane 42 degrees north of west for 70 miles. So I'm going to kind of think about this as doing like a new vector. So now the plane is here at the end of the vector. So I'm going to kind of add like another little, here's again north and here's south. And then I need to turn 42 degrees north of west location. So starting from the west, going to the north, 42 degrees. So you can think about this as taking off 42 degrees from 180, and that's going to give me an angle measurement of 138. And I'm going to go in this direction for 70 miles. Okay, so I'm going to get this new vector for this distance that I've traveled. Okay, and they want us to find the plane's resultant distance and direction from the starting point. So we want to take these two vectors, and what we're going to do is we're going to actually combine them into a new vector. So let's call our first vector, this is vector W. We'll call our second vector, vector V. And what we're going to find is our two combined vectors. So we're going to combine our two vectors to find this total motion. So we're going to take our W vector plus our V vector. If you remember from our last video about adding vectors, you just add the two X components and you add the two Y components together, and that will get you a brand new vector. Okay, so once you have your combined vector, this is the new vector that represents this total combined motion, and it's kind of, again, from the original starting place of the plane to its new location. If I want to find the resultant distance that this plane has traveled, well, what I want is the magnitude of this vector. So if I say distance, well, we were using distance for the magnitude, so what I want is the magnitude. And to find direction, I want the angle. Remembering those formulas from our video yesterday, magnitude is the square root of the x squared plus y squared. Okay, and my magnitude is 207.4 miles. And to find my angle measurement, I need to do the tangent inverse of y over x. Okay, because tangent inverse can sometimes be in the wrong quadrant, you always want to check. Negative 13 degrees is going to be in quadrant 4. So I need to get to my correct quadrant, so I'm going to add 180. And that gives me an angle measurement of 167 degrees. If I want to put this back in terms of the problem, well, I need to figure out how off of 180 degrees that is. So if I'm at 167, I can say, well, that's been 13 degrees north of west. So there's the new direction of the plane and the new distance. Okay, our next example is going to be combining two different motions. So we've got a ferry shuttling people from one side of the river to the other. The speed of the ferry in still water is 25 miles per hour. The river flows directly north at 9 miles per hour. If the ferry is heading directly east, what are the ferry's resultant speed and direction? Okay, again, like all problems, I'm going to start by setting up my compass. Okay, and we have two things that are happening here. The ferry is moving. The ferry in still water travels 25 miles per hour, and the ferry is headed directly east. So I'm going to draw that vector for the ferry. I am also going to go ahead and find the equation, or the vector in component form. Okay, now we have a river, and the river is also has motion involved as well. The river is flowing directly north at 9 miles per hour. So I'm going to show this river as a vector of space as well, going directly north at 9 miles per hour. I'm also going to calculate this river vector. And now what we want to talk about is what happens when the ferry is in this river, right? So the first, we knew that the ferry was traveling 25 miles per hour directly east, but it is in this river that's also has motion involved too. So what we really want to talk about is, well, how is the ferry flying, or how is a ferry traveling with the river? To do this, we're going to look at their combined vector of ferry plus river. And again, I think we should add units. Again, these are both mile per hour units. Okay, so once we have their combined vector, we want to answer the questions that they're asking. The first question that they're asking is, what is the resultant speed and direction? Well, the speed is the magnitude that we were using, so speed means magnitude, and direction is always going to be an angle. Pause the video and see if you can find these values on your own. Okay, so this angle makes sense. It's got 19.8 degrees. It would make sense if this would fall in quadrant 1, right? You can think about this as this ferry vector is kind of being pushed a little bit to the north because the river is flowing to the north. So this vector is getting a little bit longer. So the river is actually increasing the speed of the ferry, and it is pushing it off course a little bit by 19.8 degrees. So to answer that 19.8 degrees, we might say that this is northwest, or you might say that this is north of east. Okay, the last example that we'll cover is another problem similar to the last one. Here we have, without wind, a plane would fly north 30 degrees east at 450 miles per hour. The wind is blowing at a 45-degree angle south of east at a rate of 25 miles per hour, and we're going to find the new bearing of the plane. See if you can pause the video, draw your vectors, and find the two individual vectors of the two motions. Okay, I have my plane vector. The magnitude of the plane was 450 miles per hour. The angle of the plane is at 60 degrees because it was north 30 degrees east. So that put me at 60 degrees. And I calculated my plane vector, which is 225 and 389.7 miles per hour. Then I have my wind vector. The wind vector is 45 degrees south of east. So I'm going to go towards south from east position. So I took 45 degrees off of 360, give me an angle measurement of 315. This wind is significantly less powerful than the plane, so I drew a smaller vector for that. It gave me a wind of 25 miles per hour. I set up my wind vector and I calculated my wind vector, and again, this should be miles per hour. Okay, now we're going to find the new bearing of the plane with the wind. So we want to find our combined bearing of plane and wind. So I'm going to add my two vectors together and then find the bearing. And the only thing they asked me for is the bearing, so I'm going to find the direction angle. And I'm going to check to make sure that makes sense. So my plane is moving in the northeast quadrant, and it is significantly more powerful than the wind. So the wind shouldn't push it off into like the southeast quadrant. It should stay relatively in that northeast quadrant. And it does. It's going towards 57 degrees. So we can say that this is north 33 degrees to the east, right? That's 3 more degrees than the 60 degrees that it was originally facing. So we can say that this is the new bearing of the plane.